Let's create this simple line chart with D3 that shows the Keeling Curve data. This involves using scale time to deal with dates, using D3's line generator capabilities, and using an SVG path to create this line. Now that we have all the data loaded and parsed, let's go ahead and make this Keeling curve visualization, a line chart, with D3. We can do this by starting with this scatter plot and pulling in this data and then changing the marks from points to a line. I'll start by forking simple scatter plot and I'll call it simple line chart. And then I'll modify this to pull in the data from the Keeling curve dataset. Instead of importing from penguins, we import from Keeling curve data. And of course that breaks because we need to change x value to be d.date, and we'll change that label to say year. And then the y value will need to be changed to be something. Let's see what that something is by taking a look at that sample row. Okay, it's just CO2. So the y value can be d dot CO2. And we can change the label to say CO2 ppm parts per million. And that gets us pretty close, actually. This is actually very nice because immediately we can see the trend and we can see where there's missing data. And if I just bring the circle radius down a bit, it starts to really come into focus. There are only really a couple changes from here that we need to make. One is we need to make the x-axis look decent by using a time scale, not a linear scale. See, the labels are crap right now. And then instead of circles, we render a line, which is actually a path, an SVG path. And then we need to handle the missing data. And I think that would reasonably translate to, just missing chunks of line. So let's see if we can do those three things. Okay, over in viz.js, we are setting up the x scale to be an instance of scale linear. Because we're dealing with dates, we can use another thing called scale time, which we need to import from D3. And if we run that, we can see that the labels update. And now we have decent labels like 1960, 1965, up to 2020. Very nice. All right, that's how you can deal with JavaScript dates and use a D3 scale time instance. Now let's change those circles into an SVG path. Okay, the code in question is right here. Instead of making circles, let's make a line. And we can do that by changing circle here to path. And also here, and CX, CY, R, and opacity don't really apply to paths. I mean, opacity could, but it wouldn't have the same effect. And if you think about it, this right here is not quite right because we don't want one path per row. No, we just want a single path for all the data. So let's change this to be null, as in this will deal with a single path. And already when I run this, I see that there's an issue because this line here disappeared. It turns out that D3 axes actually use a path element internally, so we need to deconflict. Let's take a look at what we have to deconflict with by inspecting the DOM elements of our axis. Here's a path. It's got a class of domain. Okay, so all we need to do is set a class on our path, as in svg.selectAllPath.mark. And then down here, give it a class of mark. Okay, now we've got that domain path back. And we're now left with the task of figuring out how to get this thing to show up. Let us turn to the documentation for lines. In D3, there's a thing called a line generator. But before we get to that, let's take a quick look at SVG path elements. With path elements, there's this weird attribute called D. And the value of D is this crazy looking string that is actually a domain-specific language for SVG paths that has different commands. Like M1010 is the move command to the coordinates 1010, 10 being X and 10 being Y. And then there's H, which I guess is like move horizontally, V, which is move vertically, and L, I don't know, there's a bunch of commands here. So the idea is that we are going to manage a single path element that's going to contain the line for our line chart, and then we're going to delegate to D3, namely a line generator, the responsibility of coming up with this crazy string that we can assign to the D attribute of our path. Back to the D3 documentation, we can create a line generator, and we can pass in two functions, a function that computes the X coordinate and a function that computes the Y coordinate. So let's try that. Over in our line chart code, before we set up all this, we can create a line generator by invoking d3.line, and we need to import line from D3. That leaves us with a naming conflict. So I'm going to rename this one to line generator. And now we just need to figure out what these functions should be. And check out the code we had before with our circles. I'm just going to move that up here for reference, because I'm pretty sure that's what these need to be. We take the row and pass it through our accessor function and pass it through our scale. So let's just specify both of those here, and that should be the correct definition. I'm just missing some parens. Okay, so now let's use this line generator to define the attribute called D. And we can do that by passing in our data to that line generator. And when that runs, it looks like nothing is showing up. We may need to set up the stroke or the fill. Let me try the stroke to be black. No, that didn't quite work. It looks like we have some not a numbers. Aha! We need to handle the missing data, of course. Okay, the line generator has a way of dealing with this. Namely, line.defined. And that defaults to always return true. But as in the example here, we should use a function that checks if a certain attribute or column is defined. And what this does is, well, it says here, the defined accessor will be invoked for each element. And if it returns true, the point will be added to the current line segment. Otherwise, the element will be skipped. The current segment will be ended, and a new line segment will be generated for the next defined point. This will translate to something like this with actual gaps in the line. All right, so let's apply this idea in our code here by invoking .defined. And the thing that is coming up undefined for us is the y value. So we can pass a function that takes as input d and then passes d into our y value accessor. And this expression can be simplified to just pass our y value accessor like that. And boom, it shows up. Amazing. By default, fill is set to black, so that's why we're getting this jagged edge effect. Well, let's change that by just setting the fill attribute to be none. And there it is. There's the Keeling curve. And it even has missing line segments. All right, that's how you can make a simple line chart with D3. To recap, here are the changes we made. We modified the data import to pull in the Keeling curve data. We changed the configuration of our viz function regarding the meaning of x and y. In our viz function, we changed scale linear to scale time to deal with dates. And then instead of rendering circles, we changed it to render an SVG path as the line of the line chart using a D3 line generator, which is configured with these functions to compute x and y, and also a function to figure out whether data values are defined. That results in these gaps. And here's a challenge for you. Fork this viz and modify it to show your data. And keep in mind, line charts are not the best fit for all sorts of data. Usually it only makes sense if you have time and a single quantitative attribute. Good luck!